Welcome to this video on the packaging process for a JFET. We will demonstrate how a wafer that has been through the semiconductor process is transformed into a finished product. In this case, we will showcase the operations needed to enclose a JFET in a metal case. There are many individual procedures involved, but this video will focus only on the significant steps that are necessary. It all begins with a processed silicon wafer. The deposition and photolithography operations have created thousands of JFETs on the wafer, but they are connected by the silicon substrate. The first major step on the path to usable transistors is to separate the individual transistors from each other. This is referred to as the sawing process. The entire wafer is tightly bounded to a thin blue film to prevent parts that have been separated by the saw from falling away after being cut. The wafer is mounted to a round metal plate and held in place with a vacuum. An extremely narrow circular saw blade, usually made of a nickel alloy, embedded with diamond chips, is used to cut away the material between the individual JFETs. The saw blade passes over the wafer in a straight line, then indexes to the next row and reverses direction. That process is repeated until the entire wafer has been completed. Care must be used to ensure that the saw cuts only between the JFETs. The wafer is constantly flushed with a combination of water and surfactant to remove the residue of the substrate. When the process is complete, the JFETs are now individual parts held in place on a flexible backing film. After sawing, the individual JFETs need to be removed from the backing film and placed into the cells of a carrier that is called a waffle pack. The waffle pack is made of a polycarbonate or polypropylene material and has an interlocking top that can be held in place with external clips. This allows the die to be protected and the parts to remain separated during transport or storage. There are many sizes and depths of waffle packs. A commonly available waffle pack is 2 inches on a side and contains 400 individual cells. After the die have been placed in the waffle pack, that pack is transported to another station for the next major step, die attach. This is where the distinct die are bounded to the base of the metal case. The metal case consists of two parts, a base and a lid. The base is a gold-plated metal disc made of a special alloy called Covar. This combination of 54% iron, 29% nickel, and 17% cobalt is used because its coefficient of thermal expansion is controlled to match that of the borosilicate glass that is used to provide a seal around the pins that penetrate the base. The empty bases are arranged in a carrier that is a single row and are retained between a lower guide with a star-shaped hole and an upper guide with a circular hole. First, a small amount of an epoxy with embedded silver particles is dispensed on the base. This epoxy, when cured, is electrically conductive. In this example, an operator is placing 2 small dots of epoxy on a ceramic separator that is already attached to the base of the metal case. This specific part is composed of 2 die in each metal case. The white ceramic rectangle is an insulator that prevents electrical interaction between the 2 die. After each has received the conductive epoxy, she retracts the retainer to begin at the beginning, and this time, through carefully placing a JFET die in each epoxy drop, taking care to orient the die properly. She uses the protruding pin as an extra hand to rotate the die into proper alignment before carefully placing it on the epoxy. The syringe is a vacuum needle that will provide a slight vacuum to allow the die to be manipulated without damage. She again works her way through the linear array of parts to complete the die attach process. The silver epoxy used to mount the die to the base must be cured to reach full strength and allow all vapor components to be removed. A general cure schedule is 1 hour at 300 degrees Fahrenheit. After curing the parts, an electrical connection must be established between the now mounted die and the pins that protrude through the bottom of the case. This is accomplished by using an ultrasonic welder to bond a thin thread of gold wire between the die itself and the flat top of the pin that passes down through the base. After the bond wire is disconnected at the pin, an electrode will be used to prepare the golden thread for the next attachment to the die. After all the pins have been attached, they are ready to have the lid welded on. This is similar to spot welding. To begin with, the parts are placed into an interlock area where heater will remove the moisture from the air. Then, after a sufficient amount of time, they can be brought into a controlled workspace of the welder. Here a lid is installed in the lower electrode and the part is installed in the upper electrode. The two parts are pressed together with about 30 pounds of pressure. Then a series of electrical pulses are passed through the junction between the lid and the base. This high current will allow the junction to become plastic, and the two parts will be permanently joined. After all parts have been welded, they are returned to the interlock area where they can be removed when the next set of incoming parts is ready. Here we can see examples of JFETs that have been enclosed in metal cases. There are many configurations with different diameters and number of pins. If you enjoyed this video, give it a thumbs up and subscribe for more expert insights into JFETs, analog design, and low-power electronics. Hit the bell icon so you never miss an update from InterFET. Got questions or ideas for future videos? Drop them in the comments. We'd love to hear from you. Interested in using JFETs in your next project? Reach out to us directly through our website or the link in the description to speak with our team of experts. Stay connected, stay curious, and keep innovating with InterFET.